Yeah, good afternoon all. Am I audible? Yeah, am I audible? Yeah, am I audible? Am I audible? Could anyone confirm whether I'm audible or not?
Yes, sir.
Yeah, okay. So good afternoon, one and all. So today we are here for the lecture on nanoparticle quantification. I hope the slides is visible. Yeah, I hope the slides are visible, right? Anyone can confirm?
Yes, sir. Visible.
Okay, so in this lecture, we would be having a quick look, or otherwise a short look about the nanoparticle quantification. So how to quantify the nanoparticle and then how to detect the nanoparticle using one or combination of couple of more techniques. So moving on. So with respect to the challenges or with respect to the nanoparticle detection challenges. So where are we going to detect is one such primary question. So the question is mainly with respect to water as well as wastewater. We had discussed in this thing in detail with respect to the previous sessions, be it the nanoparticles, leakage, or otherwise nanoparticles flow in water as well as wastewater streams. The source, again, where does it come from? Mainly from the products. So with respect to the products having nanoparticles is very huge in the consumer market. And then still the quantification or the publicization of data or the availability of data with respect to the nanoparticle containing in the specific products is completely missing. So that is one such drawback. Then the release and fate studies are still relatively not up to the mark, I can say, to really quantify the quantum of nanoparticles that is being present in the wastewater stream, especially the mixture toxic effect are still studies are not still out yet, and then still they most of the studies are looking for only one nanoparticles, either it is aerobic or anaerobic studies. How do they behave? Be it the membrane, or otherwise be it the activated sludge process, or be it the USB reactors, or be it the methane generation, how these nanoparticles affect those. But still in real-time scenario, the scenario is completely, or real-time data, the scenario is completely different. With respect to toxicological and ecotoxicological studies, again, lab scale studies have yielded results. And then based upon that, there is a concrete evidence about the impact of these nanoparticles onto the exposed microorganisms. And monitorization of engineered nanoparticles in environment and organisms. So in environment, it is pretty difficult. At the same time, with respect to organisms, again, more number of studies needs to be there in the public domain, so only it will be possible to arrive at a conclusion with respect to the monitoring aspect. So as the availability is huge, again, that will automatically or otherwise directly be in relation with respect to, or it will be reflecting that in the waste water stream. So that means the concentration of these nanoparticles or engineered nanomaterials availability will be plenty in the wastewater stream. Again, as once it keeps going on to the top, or otherwise once it is there, moving there in the wastewater stream, again, there will be a big challenge with respect to the complexity that is being involved. So again, just a minute, I'll stop here. So just a minute, I will be joining again back. Yeah, excuse me for the delay. Yeah. So with respect to the availability of these nanoparticles or products containing nanoparticles, presence in environment is too huge. So obviously, their concentration in the environment will also be increasing. So with respect to once their concentration, the number as well as the variations or the various type of nanoparticles being present in the water or wastewater stream, again, the complexity that is involved in arriving at their relative concentration in the respective stream also increases. So over one such thing is that though with respect to the products we can able to identify, but once they are there in the waste stream, their presence as well as detection is completely difficult get in the real-time scenario. And then with respect to different products, not only from the consumer product, but also from the industries also release these nanoparticles into the environment, mainly from the polymer sides or otherwise the cosmetics or textile industries, which release their nanoparticle into the waste stream. And laboratory experiments involving the release of engineered nanoparticles from the consumer group, as well as their fate in the environment, is still relatively not done to the maximum level. So with respect to the fate and transformation of these nanoparticles in lab scale as well as in the real-time scenario, must be in such a way that it needs to go hand on hand. But as of now, there are numerous lab scale studies, but still with respect to the real-time monitoring of these nanoparticles in the water or wastewater stream is relatively scarce. Monitoring their occurrence as well as determining their fate in the environment as well as with respect to the particular organism is still not done to the maximum level. So all these challenges are there in front of us before these nanoparticles are being detected on a continuous mode. With respect to the transformation, why it is being difficult for us to determine their presence in the environment. So one such thing is there, nanoparticle transformations. So already we had looked into the types of transformation that the nanoparticle has. So be it the aggregation, in aggregation, either it can be homo as well as heteroaggregation. followed by the nanoparticles can dissolute or otherwise release metal ions, or sulfidation can happen where they can react with ligands so that they can transform, as well as they can also combine with natural organic matter so that they also change their size, as well as they can move on, or otherwise they will be there as a stable entity. So they remain in the fixed position, and then those type of nanoparticles are relatively very low. But with respect to the transformation that happens, either it absorbs onto any specific media, be it the biofilm or towards the biomass, or any such physiochemical transformation happens. Either they react with sunlight and then they generate reactive oxygen species is also one such thing. With respect to any material, once the nanoparticle gets released, so as mentioned, so the nanoparticle dissolutes, releases metal ions, hormone heteroaggregation can happen, ligands, with respect to ligands, as I mentioned, they can just be in touch with the ligands, silver sulfide can be formed in anaerobic setup, as well as with respect to natural organic matter, they can again get their size differed when compared to their original size. So all these transformations happen, and then there is no such specific control over it. So that makes the process really tough for everyone to detect these concentrations in real time as well as in the laboratory scale. So how to prepare the sample, or otherwise once you collect the sample, what are the ways or what are the techniques that are available as such, or there is no single standard technique that is there to say that, okay, this is one such technique that you can use and then you can able to arrive at. But still, in order to arrive at a concrete evidence, it is always advised to use two or more number of techniques in order to arrive at the exact concentration of these nanoparticles. So one such thing is that as like the materials. So one such sample preparation is the digestion of sample. So you digest the sample. So once you say that digestion, it is nothing but addition of acids to the sample. So digestion of solid samples, be it from the organic or inorganic nanomaterials. So let us take the example of inorganic nanomaterials, and then so which involve, so they can be from any type. And then involve the dissolution of these nanomaterials and degradation of the sample matrix or both. So these can happen both. So they can also dissolute and then they can also degrade. So with respect to sample digestion, two or three different acids are used. Mostly hydrochloric acid or sulfuric acid is being used to digest the sample. So in combination with sulfuric acid, hydrochloric acid, or hydrogen peroxide or hydrochloric acid is commonly used to digest the organic matrices by using the very old or conventional digestion technique, by placing the sample along with the acids in the hot plate and then raising the temperature of 70 or 80 degree and maintaining it for 4 hours continuously, and then reducing the sample to a very low concentration, then filtering it and then doing it, getting it for further analysis. So under a very strong acidic condition, these nanoparticles can dissolve. So take the example of silver or copper or zinc or copper oxides. So they dissolve, whereas other nanoparticles require some other special agents. So in order to make them dissolve in the solution. So in these cases, so acid-based digestions are oriented to get information of the total element content. So not with respect to the size of nanoparticles, because you use a strong acid to dissolve them. So obviously once the acid, the nanomaterials has been dissolved, obviously the elemental content of these nanomaterials can be made available. So if the nanoparticles has been spiked onto the solution, and then those solution over the period of time after its analysis are being taken for sample digestion. Once the sample is digested, then you will be able to arrive at the elemental composition of the nanoparticles in the sample, or acid digested sample, you can say. So with respect to separation techniques, so as the name itself says that there are you separate the nanomaterials from the media. So be it the water or otherwise the wastewater. How to separate? So one such a simple thing is how the basic question when it comes for separation is that what is the concentration of these nanomaterials. So with respect to the concentrations of these nanomaterials or nanoparticles are still relatively based upon the model values. I can say that it is still in microgram per liter of in water, be it silver or titanium, but still their concentration is pretty low. So that as their concentration is pretty low, they are not in a position to get directly measured, and at the same time, it may be necessary to remove the matrix which is present over it. That means that in the media that is being surrounded, so you need to remove them as well. So if these nanoparticles are suspended in water as well as wastewater, so you need to remove them, or otherwise the solids that is being associated, then you need, it is must to remove them. With respect to separation again, it is not only one single technique that can go ahead and then yield the results, but it can be combined with other techniques and can be useful to get a clear detection capability of these nanoparticles when combined with the other techniques. So one such separation technique that I can say is that centrifugation. So you have the nanoparticle related sample, and then with respect to this nanoparticle, you take the sample in the vial and then place it inside the centrifuge, and then this is being considered or being treated or felt that this centrifugation is one such easy step and then simplest approach to isolate the particulates, so mainly the suspended material, from the aqueous suspension, as well as to separate nanoparticles from the dissolved species. So, however, with respect to if you keep increasing the spin, or otherwise if you keep increasing the rotation, high centrifugal forces and long times, very long durations are required, and removal of nanoparticles from supernatant containing dissolved species is very tough, and then even at very high rotation speed, or otherwise then also sometimes it is not possible for us to remove those particulates from the suspension, those tiny particles. So in this thing, so centrifugation can again combine with any other techniques. So with respect to centrifugation, these particulates which are there along with the nanoparticles possesses a severe threat. So with respect to that, preventive centrifugation is not considered as an efficient technique for the fractionization of nanoparticles. So because of very high speed and then very long duration hours, this method is not being recommended or otherwise not being followed. However, this has been proved to be useful for isolation of this dissolved species when ultrafiltration as a technique, when it is being combined, or ultrafiltration doesn't perform to be there, which is expected to perform. In that case, the centrifugation can work. But apart from that, this long duration, apart from that, because of the long duration, and then it is not being preferred. With respect to the filtration technique, so normally 0.45 or less than that 0.22 micron filters are normally being used to separate out the nanoparticles from the solution, because that is the least, or otherwise that is the most commonly used, or otherwise when it comes to research community, 0.22 and 0.45 are the commonly used filter medias. So though filter 0.45 micron filters is no longer being efficient to distinguish the dissolved solids as well as particulate fractions, and serial filtrations are there kept in place in combination with ultrafiltration, so that these particles can be, or otherwise the dissolved species can be removed, and then successfully the nanoparticle can be quantified and characterized. So when it comes to characterization, so again, what do you mean by, before all the sample preparation was major thing. So how to prepare the sample, and then by the way in which the sample is being prepared, we could be able to arrive at the nanoparticle nature. So with respect to characteristics, what is the behavior, what is the nature of the particle, what is the size, what is the shape, and then how many are, what is the number concentration that they have. So again, there are several techniques. So one such technique is the use of electron microscope. So this electron microscope is one of the conventional technique and is being considered as a most successful as well as powerful technique for the analysis of nanomaterial due to its capability to visualize, so that you can able to see these nanoparticles, and it can provide information such as size, shape, or whether they have there in the aggregated state, or otherwise they are stable enough, as well as it also helps in interpretation of results when you analyze the sample with respect to other ways. So electron microscopy, though it is not being available for all the research community people, but still this is one such technique where most of the research community believes to have a very good characterization for nanoparticles especially. So among different microscopic techniques, conventional transmission electron microscopy accomplishes most of the requirement needed for the characterizations of engineered nanomaterials in complex matrix. So here, one such thing is that, let us not confuse with that. So here in electron microscope, a transmission electron microscope, there are two different microscopes. One is scanning electron and one is transmission electron, where you will get a precise information with respect to transmission, but with respect to scanning electron, assume that it is just scans the layer. So in that sense, the shape will not be able to be clearly identified with respect to the SEM, but still transmission will give you a very good quality picture. One such thing that I wanted to mention is that these nanoparticles, when it needs to be analyzed, so these are to be mounted on a copper grid, and then it needs to be dried in such a way that the nanoparticles which are there in liquid also needs to be dried on this copper grid, and then only it can be analyzed. It is not one such technique that can directly be analyzed when the nanoparticles are there in the liquid media. Compared to other microscopic techniques, transmission electron microscope offers a very high resolution, and this can be considered to give most of the nanoscale features, such as the coatings which is there available with the nanoparticle, is it there or not there. With respect to this transmission electron microscope, there is one such technique that is also being used, not many in India, but still the people in the West. It is nothing but the field emission microscope. We call it as FEM. So again, this also helps, or otherwise in combination with the TEM, you will be able to arrive at a very good characteristics of the nanoparticle that we are looking at. When compared with these two, so X-ray dispersive energy dispersive X-ray spectroscopy is also used, and then it can also be combined with TEM or SEM to detect and quantify the elements being present in the sample. So TEM, with respect to when compared to FEM or with respect to SEM, TEM can also be equipped with electron energy loss spectroscopy, which in turn is capable of giving structural as well as chemical information, including oxidation state of an element. So this also provides another edge to know about the characteristics of the nanoparticles. With respect to electron microscope, it provides a very good value with respect to the size of the nanoparticle, especially the dimension of this particle. Again, but still, it is a time-taking process. You need to sit patiently. You need to look for what is the size, and then if the sample that you pick, you dry, and then you visualize in a transmission electron microscopy, it doesn't have those nanoparticles. But again, you need to redo it several times, and then it all depends upon what focus you have. And then as you have a very good range of visualization here, you need to, this is a time-taking process, which I can say comfortably. And then with respect to the mass number of samples to be tested, again, this is one such technique that will take time. And then as I mentioned that it is not being available across most of the researchers. And then the waiting time is too huge because the number of samples that you need to do again and again is too high with respect to transmission electron microscope. So the key features in electron microscopy are the sample preparation procedures. So as I mentioned that you need to coat, or otherwise you need to place your sample, be it the powder or otherwise the liquid sample. If powder samples are there placed, you need to be there. You need to keep there in the copper grid, and then high vacuum conditions are required in order to visualize the sample inside the microscope. So followed by light scattering techniques, again as the spectroscopic techniques. So again, as the name itself suggests that it scatters the light. So the scattering light from the sample is more or less looked into. So among different light scattering techniques, dynamic light scattering or photon correlation spectroscopy is one such type that has been commonly used across different researchers across the globe. So here, dynamic light scattering again, because as the particles, so if you could able to correlate the spectroscopic cuvette size, so in that the sample will be taken. It is very recommended. To have a very relative concentration, not too low or not too high concentration of these nanoparticles. If the nanoparticles are very high, again, you need to dilute them, so ultrasonicate them so that the particle doesn't get aggregated, and then place the sample inside the dynamic DLS equipment and then start measuring the size of nanoparticles in water. With respect to microscopic techniques, all they're there in the dry form, but here in DLS, you will be able to arrive at the hydrodynamic diameter. So DLS measures the Brownian motion of nanoparticles. So again, very kinetic, which we had already discussed, through time-dependent fluctuations in scattering intensity caused by the movement of the particles, and relates this movement to an equivalent hydrodynamic diameter. This is what I have said. So this is what that we would be able to get when you have the sample in place inside the DLS. So the inability to detect the presence of very small particles when there are bigger ones compared, or relatively bigger ones when compared to the very small ones. Due to this fact, the scattering intensity depends by the 6th power of the particle diameter, and this is considered to be the biggest drawback when compared to other characterization techniques. So this DLS requires a technique require information such as viscosity and refractive index. So for each and every material, or always the nanoparticle, sometimes malware is one such equipment that where if that is one such equipment where it asks every time the viscosity and refractive index, which is not much often available for most of the samples because as they are highly complex, so it will be very difficult for us to analyze or characterize with respect to DLS. So atomic spectrometry technique. So again, this is the atoms. Once you digest the sample, you what you do is that you digest the sample, you filter the sample, or otherwise the concentrated sample is being diluted again, and it will be taken for what is it? Through the nebulizer, and then it will be in a state where you will be having a particular wavelength to visualize it, and then at last you will be able to get the concentration, otherwise the elemental concentration. So with respect to that, most of the techniques are AAS, that is atomic absorption spectroscopy, and then again in that you have graphite as well as flame. Apart from that, in order to have to know the very low concentration, or otherwise in order to determine the concentration in microgram per liter, then it would be ICP Ms would be one such thing where you digest the samples and then go on for it. So one of the most common techniques used for identification and quantification of inorganic engineered nanomaterials, which involves the use of ICP Ms due to its low detection limit. So that's, as I mentioned, that because of its very low detection limit, which is a drawback of AAS. So ICP Ms gets more famous. In any case, conventional atomic spectrometry techniques are sensitive to the element present in the sample that contains the nanomaterials, but they are not capable of providing any information about the physiochemical form of the element. So if present as dissolved species or as a particulate, or any other information related to the particles, either nanoparticles such as the size as well as the aggregation. So this is also one such a technique that has been used widely in order to arrive at the elemental composition. So moving on, single particle ICP Ms. So again, this is one such a technique that is being used across the researchers in the West, in most of the papers. Single particle ICP Ms is able to provide information about the number concentrations of nanoparticle suspension, as well as the elemental mass content per nanoparticle. What is the mass content per nanoparticle? If any other additional information about the nature of nanoparticle is available, so such as what is the shape as well as what is the density of this nanomaterials. The core size of the nanoparticles can be calculated, and the number size distribution, what is the how many number of particles in each size distribution between 10 to 20, 20 to 30, to 30 to 40, and so on. Although a single particle Icp Ms shows a great potential for nanoparticle analysis, the presence of dissolved species, again, the in the water the material along with the engineered nanoparticle possesses a severe challenge in order to have a successful detection. And then this has been used with screening purpose to detect the release of nanomaterials from plastic food containers in most of the studies. So this is one such high-end, very sensitive device where you need to have the clear solution of these nanoparticles. And then with respect to this, it needs to be worked out. So while working out, when it comes to wastewater, then it needs to be looked into detail how pure the sample is, so that the sensitivity of the device doesn't go off. So X-ray absorption spectroscopy is one such other technique where the elemental composition can be arrived at, as well as this provides the quantitative distribution of the material as well. So here for X-ray absorption spectroscopy, not much of sample preparation is needed, and the physical and chemical nature of the sample that it is being analyzed can be preserved. One of the main limitation of this study is that it requires radiation facilities that becomes very difficult sometimes to have it in place. So mostly, most of the researchers with respect to nanoparticles, they straight away go with XRD. XRD is one such technique, again, X-ray diffraction, from where you can still have, with respect to the software, the elements being present, as well as d by square equation, where you'll be able to arrive at the nanoparticle size as well. Apart from this, the researchers also go for electron microscopic techniques as well as DLS, and then AFM as well. That will give you the the surface of the nanoparticles, how smooth and how rough it is. So this, excuse me. So this table shows you a different perspective. So none of the studies, or most of the studies, have gone in combination to determine the one such thing is that the presence of nanoparticle, that is one such thing, or otherwise the quantitative assessment of these nanoparticles in the water or wastewater. So there is always a combination of methods. So be it AAS or ICP or electron microscope or a single electron microscope or XAS or XRAS. So all these are being used in combination, so that in order to get a better results, and then that will also help the researchers to sell off their papers in a best way. So moving on, so one such case study was, let us see one such case study where how the nanoparticle and what are the challenges. And then this was one of the earliest studies, I can say, that in order to determine the or otherwise take and look up the waters as well as the wastewater in different places that look for their concentration, which is available or not, the concentration of these nanoparticles. So for that, one such technique was used. Or a combination of techniques that we have discussed here was used to arrive in one of the both qualitative as well as quantitative analysis was done in order to arrive at the evidence of these nanoparticles in Indian wastewater. So for that, the techniques that were used is nothing but the dynamic light scattering, that is nothing but the Z average diameter, the transmission electron microscopy in order to arrive at the size as well as the shape of nanoparticles in different water system, X-ray fluorescence for the elemental composition, as well as Icp Ms in order to know the concentration which is available at a very, very low concentration, especially for the water case. As such, the samples, though, as you are well aware of the limitations of each study, so as we have discussed now, the nature of water that we collected was also different from different places. So initial screening or pre-treatment was found to be necessary. And then once the water was collected, be it the water as well as the wastewater, it was the suspended solids were removed, as well as it was filtered with 0.45 as well as 0.22 micron. And then the leftover was analyzed with respect to all the other, with respect to the techniques that was mentioned here. So 6 different samples were picked up. So one such thing, sample 1 and sample 2 are nothing but the inlet and outlet of the wastewater treatment plants. As in the yesterday session also, I highlighted some of the researchers in the Western world. So say Limbach or Paul Westerhoff group from Arizona State University or Otto Killer, they had also looked into the concentration of these nanoparticles in treatment system, treatment unit systems. So one such attempt was also made where the influent as well as the effluent of the treatment units were picked up. They had been screened or pre-treated, and then in same case, 2 different wastewater treatment systems were picked up. So one with extended aeration as a process, and then one with activated sludge as a process. So this also gives indirectly the uh, um, indirectly the treatment efficiency of the units that are there in place. So, and then the 5th and 6th sample was supposed to be the groundwater as well as the surface water sample. So groundwater was mainly collected so that it doesn't have any contamination, and then that was within an educational institution. So the chances of getting contaminated or otherwise will be very low. With respect to the surface water, river Yamuna was picked up because due to its nearby vicinity, and then sample was picked up at a specific location. So all the analysis was done thrice, and then with respect to the pre-treatment approach, the nanoparticles were filtered, as I mentioned, that filtration of point with respect to 0.22 micron, and then after that, it was very clear that these nanoparticles of less than size of say 100 nanometers were predominantly found, and then even the treatment efficiency of the units were also be found to be interesting. So with respect to the inlet and outlet, so there was a significant change of the size of the nanoparticles was found, as well as this also affirms or otherwise confirms the treatment efficiency of the units. Otherwise, the nanoparticle getting onto the sludge is also getting confirmed. So with respect to S1 and S2 is nothing but the samples. S1 is nothing but the inlet as well as the outlet, as well as this with the empty one is nothing but the DLS with using DLS, and then this is with respect to the TEM, transmission electron microscopy, and then more or less the values were found to be more or less with respect to plus or minus 50 to 75 nanometer size range. And with respect to S3 and S4, again, this was with respect to the activated sludge process. And then with respect to S5, there were very low concentrations. There are very minute colloids, we can say. And then with respect to S6, the concentration of the particles of size less than, say, 200 or 500 nanometers was too huge. And then that's what that was also being confirmed with respect to the transmission electron microscope. With respect to their visualization. So again, different different samples were taken, and then it was analyzed, and then the very minute particles, sorry, the particles of very minute range, say less than 50 nanometer as well as less than 500 nanometer were observed. And then in summary, it was also it was with respect to metal ion concentration. So this was here you could able to determine this was nothing but with respect to the size, and then the sampling sites, and then on the y-axis again, on the other y-axis it is nothing but the metal ion concentration. So with respect to metal ion concentration, 3 different nanoparticles were looked in. One was silver, one was titanium, and then one was zinc. So based upon the percentage of their share in the consumer product, based upon a survey that was conducted with respect to the nanotechnology project, or otherwise a site which has the even Professor Lok was also mentioning about that. So with respect to this, the concentration of these nanoparticles was found to be pretty low, but not to be having a very high significant value. And with respect to the surface water body, it was found that different components, metal components, were found to be there because of many non-point sources being entering into the wastewater stream or otherwise water stream. And then out of the metals, one such thing is copper, manganese, as well as titanium was found to be predominantly high when compared to the other nanoparticles or otherwise other metal components which is being present there. So with respect to the summary, we could able to arrive at the 90% of the particles with respect to the particle size distribution when done with dynamic light scattering, it was found to be greater than 250 nanometers in size. And then again, so that again gets onto the sludge and then everything. And then least size of particles were found in groundwater samples, very least, and large size fraction was found to be in the inlet of wastewater treatment plant too. This wastewater treatment plant, when compared to when you look at the nature of both the treatment plants, one is a relatively new treatment plant which caters the public or otherwise the domestic treatment of wastewater. But at the same time, the second wastewater treatment plant receives both industrial as well as the small industrial units wastewater as well as the domestic wastewater use. So obviously this size, greater size when compared to the size with respect to the treatment plant one might be due to the industrial, small scale industrial activity nearby in the place. So extended aeration process had 42% reduction in size of the particles, whereas 58% reduction was found to be in the plant operating with activated fluids process. This was also on similar lines with respect to the available study that was there. And then this also confirms that the treatment units, though knowingly or unknowingly, removes certain concentration of these nanoparticles from the stream. But again, their aftermath as well as the risk towards the environment as well as risk towards the humans are still needs to be quantified in a greater extent. So with respect to transmission electron microscopic analysis, both individual as well as aggregated particles of various shapes were found in the transmission in the electron microscope. And then with respect to XRF analysis, the metal or the elemental composition analysis, it was found that silver, titanium, and zinc concentration were found to be predominantly high, and then titanium followed by silver, and then zinc were found to be very high in concentration with respect to the surface water bodies. So in this case, this is one such attempt that was made to the attempt which you can able to see here of different water qualities were taken and considered. When you go, as mentioned earlier, with respect to the restrictions of each and every equipment that we have, each and every equipments have one such limitation. So with respect to the concentration, though they are there in the microgram per liter, but still the digestion as well as filtration and then as well as their concentration, very minute level concentration was found to be reported in all the locations of the surface water body. Only one surface water body was groundwater body. Only one was reported, but when more number of samples were taken and analyzed, still their concentration was found to be very low. But when down the stream of once the sample location for this surface water body was chosen in such a way that it was outside of the city, but still it could be able to receive at the outskirts of the city only. Most of the industrial units were there in place, and then their metal concentrations were very high when looked for their metal analysis. At the same time, when it was looked with respect to the surface water sample under TEM, sample size of greater than say around the size range was between 200 to 300 was found, and then that was also being due to the activity or industrial activity that we can say. So with respect to the nanoparticle detection as well as characterization, it involves huge time as well as the limitations for each and every product. Every technique is unique in such a way that so you need to combine, you need to compare, and then you would be able to produce the, otherwise you would be in a position to communicate the results in a conformed manner. So So that's it for today's lecture. And then if you have any such queries, then we can discuss.
Yes, sir.
Yeah.
Yeah. In the case of filtration using 0.22 or 0.45 micron filter, we'll be having particles lesser than that and dissolved ions also, right?
Yeah.
So it has been, the metal ion concentration has been overestimated, right then?
Come back again. I'm not able to get it. See, we had filtered the sample with 0.22. Yes. And then, yeah, after that, I could not able to get you properly.
Yeah. Then the concentration measured will include that metal ion concentration also, right? Ionic concentration.
See, the filtered sample without digestion was taken for DLS, and then the hydrodynamic diameter was determined, and then the sample that was collected after filtration was taken to digestion, and then through ICP we could be able to get the metal ion concentration.
Yes. Nanoparticle concentration, how can we arrive?
Yeah, that's what we could not able to see. We are not directly in a position to arrive at the nanoparticle concentration, but with respect to the elemental concentration, we could able to correlate the presence with respect to the DLS as well as TEM. We could able to say that this can be there from the nanoparticle source.
Yeah, but that DLS and TEM can tell both inorganic particle or organic particle, any particle it will show, right? So how can we arrive at those are from inorganic nanoparticles?
See, again, you need to cross verify your data with respect to, see, EDX will give you the elemental composition of inorganic materials in the sample.
Yes.
So in that sense, again, you need to cross verify your results with respect to the ICP value that you have received. So in that sense, that's what I was mentioning. It is not one such technique that will help you out in arriving at the concentration, but still, combination of these techniques will help us to narrow down their what to say, or otherwise, will help us in arriving at their, otherwise concluding the results. I say that. See, with TEM EDX, you would be able to get the elemental composition, and then at the same time, if you get those, you compare it with ICP as well as whether those concentration has been there in the sample. So with that, you will be able to arrive at the metal elemental composition of the metals. And then now you look upon the DLS as well as TEM, whether the size range or otherwise what are the metals which are being present. And then if you look at that particular, again, with respect to TEM, as I mentioned, that is time taking, you would be able to look only that specific area. So in that, you could be able to close on that, okay, this might be the source of the nanoparticle might be the source for this element.
Yeah, but as you have told, we cannot concretely tell that.
Yeah. See, the with respect to the characterization, still the concrete evidence, or otherwise 100% we would not be able to say because of the complexity that is being involved in sampling, in analyzing, and then in characterization as well.
Yes. So, sir, can you tell me anywhere this Icp Ms is available here in India? Single particle?
Yeah, see, actually, Sabrinathan, I feel that in India it was not available. I also tried once, but it is available in the West, so where they do it for samples. So one such thing that I can help you out is that I can give you way, as I also aware that you work on nanoparticles, and then right. So you can in that sense, if you are looking for analyzing the sample or picking up the natural sample and do it, so you can apply for a call, that is an Indo-US call, where you would be having a 6-month stint at your US partner where you can take the sample and analyze it. I have forgotten the call name, so I also applied for that, but I could not able to convert that call into a successful one.
So Fulbright, when you are telling, sir?
Fulbright. Not Fulbright.
Vari.
Nebraska Lincoln. Nebraska. Vari. Nebraska. Vari again. It's first. Yeah. Vari is also water research initiative. I think that I think it's a Vari fellowship. I feel. Yeah. With they had the connect with Nebraska Lincoln and other couple of institutes. So once you go there, then you would be in a position to. I think if they have it, then you would be in a position to do that ICP Ms.
Yes, yeah, I was also struggling for.
No, that again, it involves which medium that you are looking in, whether it is water. Water is the matrix that you are working, or wastewater is the matrix.
Wastewater, sir.
So yeah, and then again, with respect to wastewater, it is still a challenging job.
Yes,
I wish you could be able to successfully do that if you get a partner from the other part of the world. So in that sense, you would be able to do it. But as far as I am concerned in India, I have according to my knowledge, I don't think it is available here.
Yes, sir. Thank you, sir.
Yeah. Okay. So I hope you will get the access to it, and then all the very best for your analysis as well.
Yes. Thank you.
Yeah. So I think if there are no questions, then we can wind up this session. And then if there are any questions still, we can have one such a discussion session after tomorrow's Lok's lecture after 11 o'clock. And then so there would be this is one such information that I will pass on with respect to in the WhatsApp group as well. So at tomorrow at 11 to 11:30, there would be a part of extension of this, and then the course will be ending by 11:30. I will be passing on the information this in the WhatsApp group as well. So kindly be prepared for it. Otherwise, if you have any other prior appointments, kindly make sure that you are available between 11 to 11:30. So yeah, thank you. So thanks for joining. So let us